Now this video is going to be about calculating percent composition, but before I get to that, I'm going to start with a review of calculating formula mass, because calculating formula mass is a huge part of calculating percent composition. So I want to make sure that we are clear on how to do that first, but it's very easy. So here I have sodium carbonate, and I'm going to calculate the formula mass of sodium carbonate, Na2CO3. You're going to need your periodic table for this, and I've pulled all the information off of the periodic table I need so that I can show you and you can see exactly what you're going to do. But all you'll really need is the atomic masses of the elements in the formula. So here I can see that there are 2 sodium, so I just need to add in 2 sodium and multiply 2 times the atomic mass of sodium, and I'll add the atomic mass of carbon. There's only 1 carbon in this formula, so I only need to add 1 of the atomic mass of carbon. I have 3 oxygen though, so I'll add 3 times 15.999, and it really is that easy. So you just put all that in your calculator, and I find that the formula mass of sodium carbonate is 84.998 grams. All right, so just one more formula mass review problem here so that you can see how we do this. All right, so I'm going to have 3 carbons, so I'll need 3 times the mass of carbon. I have 7 hydrogen, so I need 7 times the mass of hydrogen, and just 1 oxygen. So I just add all of that up, and the formula mass of C3H7O is 59.088 grams. So now that we reviewed formula mass, we can jump to our percent composition problems. All right, so here's our first percent composition problem. It asks what percentage of the molar mass of calcium chloride is derived from chloride ions. So you can see we have our formula for percent composition here at the bottom. It's not on your formula chart, so I've put it on this slide here. And it tells us that we need the mass of the element divided by the formula mass of the compound times 100. And so we're going to start by figuring out the mass of the element. And you can see that we have 2 chloride ions. So I'm going to figure out the mass of Cl2, and that is 2 times the mass of chlorine, which is 70.906 grams. And now I need to figure out the formula mass, and this is the same thing as the molar mass, the mass of 1 mole of calcium chloride. And so this is what we reviewed to begin with, CaCl2, and calcium has a mass of 40.078 grams, and there's only 1 calcium, so I don't need to multiply that by anything. And then I just figured out that Cl2 is 70.906 grams. So CaCl2 has a formula mass of 110.984 grams. And now this just becomes a regular percentage problem like you would do in math. So the part, 70.906 grams, that's the Cl2, divided by the whole. That's all we're really doing here. Times 100. And that gives us a percent composition of 63.9%. So that is the answer to this question. The chloride ions account for 63.9% of the mass of calcium chloride. So our next practice problem here, what percentage of the mass of 1 mole of CH3F is derived from hydrogen? So we're looking at hydrogen, and there are 3 hydrogens in this formula. And so remember from our formula, I need the mass of the element and then the formula mass of the whole compound. So I'll start by figuring out the mass of just hydrogen, so H3, so 3 times the mass of hydrogen equals 3.024 grams. Now I'm going to figure out the formula mass of the entire compound. So I have one carbon, and that has an atomic mass of 12.011 grams. I just figured out that my three hydrogens combine for a mass of 3.024 grams. And I have one fluorine, and that is the mass of fluorine right there. And so the formula mass of CH3F is 34.033 grams. So now, to find my percent composition, I'm just going to do some simple math to figure out what the answer is. So it's my part, 3.024, that's the mass of the element, divided by my whole, which is the formula mass, times 100. So the mass of the hydrogen divided by the formula mass times 100, and that tells me that hydrogen is 8.9% of the mass of this compound. And our final problem, what is the percentage by mass of potassium in a formula unit of potassium carbonate, K2CO3? So remember that we don't have molecules of ionic compounds, we have formula units because they form crystals, not individual molecules, so don't get thrown off by that. This is just a basic percent composition problem, and I want to know about potassium, what the percent composition of potassium is in this. And remember, potassium has the symbol K. So first I'll figure out the mass of the element in this compound. And so that is 2 times 39.098 grams, which is the atomic mass of potassium. And that gives me 78.196 grams is the mass of potassium in this compound. And now I'll do the formula mass for K2CO3. I already know that potassium, both of them together, is 78.196. I've got one carbon, so I'll add just the atomic mass of carbon, and I have 3 oxygen, so I'll multiply oxygen's atomic mass by 3, and that gives me a formula mass of 138.204 grams. And now I just calculate my percent composition. So it's the amount of potassium, 78.196 grams, that's the part, divided by the formula mass, that's the whole, times 100. And I see that potassium accounts for 56.6% of the mass of potassium carbonate. So I hope this video has helped you understand how to calculate percent composition a little better. Keep up the great work, and I'll see you next time.